This is the video of the key for the last quiz on your derivative rules, your chain rule. So I'm going to go through every one of these problems. First one, f of x is equal to 2 times 4 minus 9x to the fourth. Okay, so we have a composition of functions. An inside function, I can tell is my 4 minus 9x. This is inside. Meaning the outside part of my function would be what we pretend is a big X to the fourth power. What I do when I use the chain rule is I take the derivative of the outside, I leave the inside alone, and then I take the derivative of the inside. So the derivative of this outside would be 4x cubed. Okay, the derivative of the inside would be negative 9. Now we have a constant out in front. Don't let that bother you. You do not have to use the product rule if you have a constant. You just leave that constant off to the side. Working ahead of myself. You leave this constant out on the side, and then you find the derivative of this. So we have 2 times, let's take the derivative of the outside. That would be 4x cubed, or 4, leave the inside alone, to the third power. Okay? Now I'm going to multiply that by the derivative of my inside. The derivative of my inside is negative 9. Derivative of 4 is 0. The derivative of negative 9x is negative 9. Okay? So I have 2 times 4 minus 9x cubed times negative 9. Well, I can simplify this easily by multiplying the 2 and the 4, and that's 8, and then multiplying the 8 and the negative 9, and getting negative 72 times 4 minus 9x cubed. Okay? And that's my answer. And this technically is an answer as well, but this is easy to do. Second one, h of x is root 3 minus 7x. Well, the outside function, or the inside function, is 3 minus 7x. The outside is a big X square rooted, or x to the 1/2. So really, I'm going to rewrite this as 3 minus 7x to the 1/2. Then I take the derivative of the outside, leave the inside alone, take the derivative of the inside. So h prime of x would be, the derivative of the outside would be 1/2, leave the inside alone, subtract 1 from my exponent, that's negative 1/2, times the derivative of my inside is negative 7. Now I can simplify that. Negative 7 is like negative 7 over 1, so that would go on the top of my fraction. The 2 is going to go on the bottom of my fraction, and this 3 minus 7x will be moved as well. So we'll have negative 7 up top, we'll have 2 on the bottom, and then we can either write the square root of 3 minus 7x or 3 minus 7x to the 1/2. I'll just write it like this, just so you can see this is what it would look like on a test for a multiple choice answer. Moving on. 2 ways we can do this. We can either keep this like it is, this middle part, or we can rewrite the middle part as x minus 3 to the negative 1, and then all of that is squared, which really can be written as x minus 3 to the negative 2. And that's probably the easiest way to solve this problem, is using this and taking the derivative of this, not taking the derivative as we see it. But I'll show you both ways just in case. Say you did it like it is and you used the quotient rule and you kept this as it was. So the outside would be big X squared. The derivative of x squared is just 2x. So we would write that my derivative is 2 times 1 over x minus 3 to the first. I subtracted 1 from that 2. Times the derivative of my inside. Well, if I'm going to use the quotient rule, I got f prime g minus g prime f all over g squared. Well, let's start with f prime. The derivative of 1 is 0. So it's actually 0 times my g minus g prime times my f all over g squared. Well, that can simplify to be negative 1 over x minus 3 squared. So I have 2, 1 over x minus 3, and then I'll have negative 1 over x minus 3 squared. Well, I can simplify this easily. This 2 is like a 2 over a 1. So when I multiply into these fractions, I'll multiply it up top. We'll have negative 2 up top. And then in the denominator, I have x minus 3 times x minus 3 squared. So I'll have x minus 3 3 times. And this is your answer. So notice it's a little involved. You have to know that the derivative of 1 is 0 when you're doing the quotient rule. Let's see how we can do it if we simplified our function first. Well, the outside would be x to the negative second power. The derivative of x to the negative second power would be negative 2 x to the negative third, but instead we leave our inside alone. That's what the big X is. Okay? And then the derivative of the inside is just 1. So this is my answer. Of course, I can rewrite that to be negative 2 over x minus 3 cubed. So whatever way you do it, this is the answer. This is more involved. This is a lot less involved, but we get the same thing. Number 4, it's important to notice when we do number 4 that we have a composition, not a composition, but a product of two functions. This x squared we consider an f times 3x minus 2 to the fourth, we consider that a g. So if I take the derivative, I must first do f prime g and then add g prime f. F prime is 2x, g 3x minus 2 to the fourth, plus g prime. Now this is where we have to use the chain rule. So we have a big X to the fourth. Derivative of x to the fourth is 4x cubed. So we have 4, 3x minus 2 cubed times the derivative of my inside. Okay? And that's g prime, but then I have to multiply that by f. Okay? To simplify that, I would multiply the constants over here on my right together. So I have 2x, 3x minus 2 to the fourth, plus 4 times 3 times x squared. That's 12x squared times 3x minus 2 cubed. And you can just leave your answer like this. Potentially on a multiple choice, you might have to factor out an x minus 2 cubed, as well as a 2x, which is what everything shares. If you have to do that, your resultant would be 3x minus 2 after we pull out 2x and 3x minus 2 cubed, plus 6x. Okay, and then in the end, if you really wanted to simplify, or if you had to, you had 3x plus 6x, that's 9x. 9x, the 2x can distribute to that 9x. So 2x times 9x is 18x squared. So we have 3x minus 2 cubed. Here we'd have 18x squared minus 2x times negative 2 would be negative 4x. Okay? This would be, I would think, the simplest form. This, of course, is your derivative, and this is an answer. If you had to answer this on a free response, and we're not instructed to simplify in a particular way, this would be correct. Okay? Let's move on to number 5. We have the sine squared of pi t. Well, I'm going to rewrite that first and move this sine squared up and use parentheses to show that when the 2 is here, right above the sign, it's like you're taking the sine of this stuff and squaring all of it, which is really just squaring the sine of pi t. It's not like squaring pi and t. It's just the squaring of sine pi t. Okay, so we actually have a composition of three functions. We have a big X squared, we have the sine of an X, and we have just pi t, which is like pi times X. So we start by taking the derivative of the outside, which is our big X squared. That's 2 big X, which is sine of pi t, to the first, just to show you that I'm subtracting 1 from 2, times the derivative of the next piece, which is the sine of x. So the derivative of sine x is cosine x, but instead of x, I have pi t. So I have cosine pi t, times the derivative of my innermost piece, pi t, is pi. Okay? So again, this is correct. However, an easy simplification that you would be expected to do is to multiply this 2 and this pi together, and then maybe take out some parentheses to make it look nice. We'll have 2 pi sine of pi t cos of pi t. Okay? And this is the derivative. Next, g of t, it's only 2 functions, which is nice. The first function, the outermost function, is the secant of x, some big X. Okay, and this 4 is a constant, so I don't have to use the product rule because this is a constant. When I take the derivative, I can just leave the constant out on the side and then multiply by the derivative of secant t squared. Okay, so let's pretend this is an x. Taking the derivative of secant, you have secant tangent, right? But don't put x, okay? This is just a substituted x to make things look easier and easier to do. Instead, you're going to leave this inside alone. So it's secant t squared, tangent t squared. All right? That's the derivative of the outside secant, but then we need to multiply by the derivative of the inside function, which is t squared. The derivative of that is 2t. Now, when I multiply this entire thing by 4, since every piece is being multiplied together, I can just multiply this by anything I want to. Well, I'm going to multiply it by the 2t and have a nice, simplified, good-looking function, derivative function, 8t secant t squared tangent t squared. Okay? Moving on, find the equation of the line tangent to this function when x is 1. Okay, well, let's first find the function at 1. Just to find the y-coordinate that I'm going to be using. So I plug in 1 in for x. I get the square root of 1 plus 2 plus 6, 6, 7, 8, 9. So that's the square root of 9, which is 3. So that's going to be the point I use in my equation. But now I need to find the slope of my tangent of this function when x is 1. To do that, I have to find the derivative. Well, before I find the derivative, I'm going to rewrite this as a function to the 1/2 power. So the outside function would be x to the 1/2. The inside function is x squared plus 2x plus 6. Using the chain rule, we would take the derivative of the outside, leave the inside alone, subtract 1 from that 1/2, times the derivative of the inside. Now when we take the derivative of the inside, make sure we're using parentheses, because this is the derivative of the inside. So it's not just multiplying 2 over here, or the 2x over here, it's multiplying this entire thing by 2x plus 2. Okay, so it turns out if you tried to multiply this 1/2, you'd have to distribute it to the 2x and the 2. And you can do that, but before we go any further, let's just try to rewrite this nicely. So x squared plus 2x plus 6 to the negative 1/2, that's like moving this to a denominator and putting it to the power of positive 1/2. The 2 will be down there. This 2x plus 2 would be up in the numerator because it's like 2x plus 2 over 1. So I have in the numerator 2x plus 2, and in the denominator I'll have 2 times the square root, because that's what the 1/2 power is, of x squared plus 2x plus 6. It's supposed to be a 2 right here. Okay, and again, if I wanted to, I could simplify by distributing this 1/2 into the 2, or by dividing both of these pieces by 2, and that would give you x plus 1 over x squared plus 2x plus 6. Okay, but if you're not comfortable doing that, don't. Just leave it like this. That way you don't make mistakes, and I can plug 1 into this function. Okay, so let's try it. Let's find f prime at 1. So 2 times 1 plus 2 is 4, divided by 2 times the quantity, 1 squared plus 2 plus 6, that's 9, so it's the square root of 9, which is just 3. So you got 4 over 2 times 3, which is 4 over 6, which is 2/3. Now, if I did simplify, you would notice you get that with the 2's pulled out. You'd have 2 over the square root of 9. Okay? Same thing. Notice, if you're not comfortable simplifying, you still get the right answer. So this is the slope of my tangent line to my function at 1, 3. So if I want the equation of that tangent line, I use the point that I generated, y minus y1, so y minus 3, is equal to my slope, 2/3, times x minus 1. Don't know why I still have that there. And this is my correct equation. Okay? Good. Moving on. Let's find the second derivative. Well, first we have to find the first derivative. So, we have a constant times a function, and this is a composition of functions. So I'll just leave the constant out the side, over to the side, and then multiply the derivative of this function. Well, this is like a big X cubed, so the outside would be X cubed, the inside would be X squared minus 1. So I'd have 2 times, I'll just put the derivative in parentheses, the derivative of the outside is 3x squared, but I'll just leave the inside alone, times the derivative of the inside, which is 2x. Okay? Now, I do not want to take a derivative of this. This will be complicated. Instead, I'm going to simplify by multiplying the 2 by the 3 by the 2x, giving me 12x times x squared minus 1 squared. Okay? Now I have to take the derivative of this. What's important to notice here is that we have a product. We have an f function times a g function. So we must use the product rule to find the derivative of this. So f double prime of x will equal f prime times g. This is f prime, this is g, plus g prime. Now g is x squared minus 1 all squared. So if you wanted to, you could actually distribute this and actually square x squared minus 1. But if you want to use the power rule, the chain rule, you can do that. Take the derivative of the outside function, which is a big X squared. That's 2 times the big X, which represents x squared minus 1, to the first power, times the derivative of my inside, okay? And that's all G prime. All of this is just G prime. But I have to remember, using the product rule, I have to multiply that by F. So this is F prime G plus G prime F. F in this situation is 12x. Okay, now again, this is a derivative. This is a second derivative. This is a good answer, but easy simplification that you'll be responsible for knowing how to do is to potentially just leave this like that, but to multiply the 2x, and the 12x together. So that's 4 times 12 is 48, and x times x is x squared. So it's 48x squared times x squared minus 1. If you wanted to, you could factor out an x squared minus 1 and a 12, but it's not necessary in most situations. I don't think you'll see something that goes this far in simplification, but just to be prepared for it. So you pull this out, you would have a x squared minus 1 plus a 4x squared. And then if we wanted to, I could simplify a little bit more. Go ahead and distribute that 12. And go ahead and combine your 4x squared with your x. That's 5x squared minus 1. Okay? So this is the derivative. This would be simplify. Up to you. Let's do number 9. Take the second derivative of this. Well, the outside function is the cos of x. So if I take the derivative of the outside, we'd have negative sine of x. Okay, take the derivative of the outside, leave the inside. Now take the derivative of the inside. Derivative of 3x squared is 6x. Okay, I'm going to rewrite this, and this is my first derivative, so that I have the negative with the 6 and the x, and then I have the sine of 3x squared. Well, again, we have a product of two functions. We have an f and a g. So I must take the derivative using the product rule. So to find the double derivative, the second derivative of my original function, let's use the product rule of my first derivative. We have negative 6 times the sine of 3x squared. So that's f prime times g plus g prime. Okay, we have to use the chain rule here. The outside would be the sine function. The inside would be 3x squared. So derivative of sine is cosine. Leave the inside. Times the derivative of the inside. Okay, and that's all just g prime. All of this. So we must remember to multiply by f. F is negative 6x. And again, make things look nice by just getting rid of some parentheses here. Also, understand that you cannot multiply this 3x squared by the 6x. This is the cosine of 3x squared. We'd have to do that first before we multiply anything. So instead, I'm just going to multiply this 6x and this negative 6x. And that's negative 36x squared cosine of 3x squared. Okay? Finally, we have our graph problems. And we're struggling on these. It's because nobody's showing their work. Everybody's jumping to answers. First thing to do is write down what the derivative of f of g of x is. Well, the derivative is the derivative of the outside, leave the inside, times the derivative of the inside. Okay? Good. Well, we're trying to evaluate when x is 3. So I'm trying to find f prime, I'll move down here, of g of 3 times g prime of 3. Okay, I replace x with 3. Well, let's go a step further. We have f prime of g of 3. Here's g, the gray line. G of 3 is 5. Well, I put 5 right here, where it is, in the parentheses that I'm taking f prime of. G prime of 3, so g prime of 3 is the slope of g at 3. The slope is 1, rise over run. Well, notice, I'm not going to multiply 5 by 1. I'm just going to find the f prime of 5. Well, here's 5, and here's f. Okay? So f prime of 5 would be the slope of f at 5. And the slope is positive 1 over 2. So f prime of 5 is 1/2. G prime of 3 is 1. I will multiply just 1/2 and 1. This 5 no longer means anything. I found the f prime of 5. So 1/2 times 1 is 1/2. That's my answer. All right, see how I worked inside out. Finally, this is our toughest one, the derivative of the roots of f of 2x. Well, I'm going to first write this as find the derivative of f of 2x all to the 1/2. Because this is going to help me use my chain rule. Okay? So the first function is x to the 1/2. The derivative of that would be 1/2, leave the inside, to the negative 1/2. Okay? But now I actually have two functions left. I don't just have 2x, I have this f. So I have to take the derivative of f of 2x. Well, the derivative of f of 2x is the derivative of f of 2x times the derivative of 2x. So this is the derivative of this. Okay, I worked from outside. I had the 1/2, and I had the f, and then I have the 2x. 3 functions. And we are evaluating this when x is 4. All right, so I'm going to plug in 4 everywhere. I'm just going to leave it as I see. Actually, I'll change this into 1 over f of 8 to the positive 1/2. This is 1 over f of 8 to the positive 1/2. I'm substituting 4 in for x. 2 times 4 is 8. Times f prime of 8 times 2. Okay? And we can immediately see that the 1/2 and the 2 are going to cancel. So we just really need to find f of 8, square root it, and multiply that by f prime of 8. Let's look at f and let's look at 8. F of 8 looks to be 6. So we have 1 over root 6 times f prime of 8, the slope of my function at 8 is rise 2, run 1, positive 2. Now, combining these, this is like 2 over 1. We would have 2 over root 6. And this is an adequate answer. You do not have to rationalize this. But if you do, multiply the top and bottom by root 6. You get 2 root 6 over 6, which is root 6 over 3. Okay, these are the same. If you rationalized, cool. If you didn't, cool. Both are acceptable. Though most likely on a multiple choice, you would find this as an answer, and you won't find this. So understand how to rationalize. Please email me if you have any questions with anything from the review, from the quiz, from any quiz. And good luck studying. I hope we study a lot and prepare ourselves for this test. Thanks.